So, I mean, as we mentioned earlier, not all honeys are created equal. So every honey, I mean, has its own properties depending on the floral source and where it is coming from, and which honeybee strain and where is the location of the bee. So let's start why honey. I mean, again, I started studying about honey with with the script that it says a drink of varying colors, honey, which is a healing for mankind. But with the keyword for here is the varying colors. So, and healing for mankind. So, which I interpret this as like a, you know, different colors of honey should have properties for different diseases. I mean, should be a healing property for different diseases. So, and then I mean, I started to look into those. I mean, which honey can be helpful for which disease and then how it can affect. So I dig into this research of analyzing the biological properties or bioactivity potential of the honey. So, and again, so honey has the potential usage as a complementary integrative medicine agent. So as we covered in earlier, I mean, in the morning, honey has antioxidant activity and its ability to produce anti-inflammatory and immunomodulatory responses, which means that it helps your immune system to fight with the diseases. And also honey has the capacity to delay the cancer development and as well as the cardiovascular disease. And honey can inhibit the bacterial development, I mean, bacterial pathogens by interfering their pathogenesis potential or virulence. And also honey can prevent some of the viral infections, or it controls the viral infections. And finally, honey can help our microbiome as being a probiotic agent. So again, which properties of honey or which components of the honey can help with these? So this is the part of my research. So just to recap, what are the components of the honey? I mean, to recover them again. So honey is based mostly sugars, about 76% sugars. In addition to this one, we have the amino acids, proteins and enzymes. We have organic acids, vitamins and minerals. In addition, we have some volatile substances like polyphenols and flavonoids. According to the National Honey Board, the nutritional profile of honey, the average, again, the amount of fructose and glucose or their ratio changes based on the nectar source. For example, in sunflower honey, the glucose level can go up to 40%. But in buckwheat honey, the glucose levels goes all the way to 30%. And then fructose goes levels high. And depending on the percentage of these, the crystallization of the honey also changes. Again, these are average values for the honeys that we produce, that we consume every day. And about 70% of honey is water. And this has been by flapping of the bees. They flap their wings to get to this percentage. And then we have about up to 7% of maltose, so which is based from the malt sugar. And we have a lot of trisaccharides and other carbohydrates, and about 1.5 sucrose. Again, not all the sucrose coming from the nectar has been converted into glucose and fructose. And then we have about 0.5% minerals, vitamins, and enzyme. And this is the key. The 0.5% makes different colors of honey and makes different properties of the honey. And honey, 1 tablespoon, which is about 21 grams, is only 60 calories. And again, as we mentioned in the morning, that the glycemic index of honey is pretty low, so it is useful as to arrange the glucose levels within the blood pretty easily. So that's why it's very helpful to start the honey in the morning, to start the day in the morning with 1 tablespoon of honey, and it prevents you from majority of diseases. Like especially for the inflammatory disease or infectious diseases. And as well, because it's an immunomodulator, so it helps your immune system to get ready all the time. So what about the carbohydrates? Those sugars. So about 75% or monosaccharides and 10% of disaccharides like the sucrose, maltose, tronose, isomaltose, and about 15% are trisaccharides, maltodextrose, and maltose. So these are, I don't want to so many technical words, but this one is changing from blossom honeys or nectars versus the honeydew honeys. And as you can see, the fructose levels can go up to 40% in honeydew and 45% in the blossom honeys. And glucose can also change between like 24 to 40%. And this is all depending on the nectar source. And what about the proteins within the honey? So proteins, when we say proteins, there are amino acids, which is the proline, And also we have the enzymes. So proline is one of the major amino acids. There are more than 20 different amino acids in honey. And these amino acids are very essential for us, to use within our body. They are the structural parts of our body. But in addition to this one, we have enzymes within the honey as well. And we have like several different enzymes. These are 8 of them. The major one is diastase or amylase. This is the one that is converting sucrose from the nectar into the glucose and fructose. And this is like every honeybee has the diastase in their honey stomach. And then they are converting the sucrose into glucose and fructose all the time. And then we have also invertase enzyme. Again, sorry, diastase is the one, the transform starch to other carbohydrates. Invertase is the one converting sucrose to glucose. And we also have glucose oxidase, which is important for the production of hydrogen peroxide. And then we have also a catalase enzyme within the honey, converting peroxide to water and oxygen. We have acid phosphatase, protease, esterase, and beta-glucosidase. So these, all of them has very important functions within the honey. And these enzymes are very fragile. That's why we should not heat the honey more than 110 Fahrenheit, because as the enzymes, they get disintegrated, they lose their three-dimensional structure once they are heated. That's why heated honey, especially in hot water or hot coffee, is not recommended. It doesn't become poisonous or toxic, but you lose the ability of those therapeutic ability of the honey once you add them into the hot liquids. So other than this, there are also several vitamins in the honey. To name a few, we have like B1, the thiamine, riboflavin, nicotinic acid, pantothenic acid, the B5, pyroxidine. So almost all the B vitamins are here, and as well as vitamin E, K, and C are so highly available within the honey. So by eating honey, actually we are getting majority of the components or the food products that we need for our body during the day, during the whole day. So can somebody survive with honey? I think so. And also there are so many different organic acids within the honey, and these organic acids are very critical, and these are changing from one sample to another, and these organic acid signature or the fingerprint within the organic acids, they are changing from source to source. And there are some studies telling the source or the nectar source of the honey, just looking or just identifying the organic acid profile of that honey sample. So this is very helpful to find out where the honey is coming from. And especially, since the last couple of decades, because there are so many foreign honeys coming into the United States, from Eastern Asia, from China, India, and Malaysia. So those honeys can be detected by finding out the organic acid within them, and then with the signature of those through using GCMS and nuclear magnetic resonance agents. So what about the polyphenols in honey? Again, this is a critical one. This is one of the parts of the organic acids. So we have both flavonoids and phenolic acids within the honey. And again, these are very important. These are very critical for the bioactivity potential of the honey. So, and then the major component or the major phenolic acid is the caffeic acid phenyl ester, which is the CAPE. And there are like dozens of studies about the activity of CAPE. It's also the active ingredient of the propolis. And the CAPE has been found also like to be successful against some of the COVID-19 treatments. So, and also these other phenolic acids, some of them are used as like ingredient of a medicine, and some of them are used for as a singular treatment, so that some people just buy them from the nutrition stores. And I already mentioned about like polyphenols as indicator of honey origin. So for example, Australian eucalyptus honey have these gallic acid, clogenic acid. On the other hand, we have Tunisian honey, which has the ellagic acid more than the others. So depending on the source, depending on the geographical origin, so the polyphenols they act as an indicator of the honey origin. And finally, as talking about all these different honeys, if we have this many types, this many differences, what about the types of honey? Normally, majority of the honeys that the beekeepers produce, they are multifloral honeys. So in order to identify a honey as a monofloral, the amount of the pollen should be 45% or more. So at least, I mean, once you do the pollen analysis or pollinology, so we just need to, under the microscope, we need to analyze the pollen contents of the honey. And if any of these pollens is more than 45%, so this honey is identified or classified as monofloral honey. And as you can see, I mean, when we ask which honey for medicine, I mean, we come up about like 75 to 80 different honey types, which has been identified. Again, this is like identified by one of the Healing with Honey, I believe that's the website. Again, this number can change, but we have honey from acacia honey to fennel honey, eucalyptus honey, rosemary, sage honey, cedar honey, or chestnut honey, even the med honey that we mentioned in the morning, or citrus honey. So there are honeys coming from different origins, which has monofloral. And all these honeys have their own texture or their own color, their own polyphenolic components. So it's very easy to find out which honey has which potential the most. But this is why we are doing this research. So we are trying to collect honey samples from different sources, and preferably monofloral sources, so to find out which honey has more bioactivity potential. So in terms of the research, I will just go into my other slide for this. This is my the research in Michigan that I have done, and then I'm going into this one right now, so to continue with my presentation. So what we did, I mean, in this research, in order to find out these polyphenolic components, so we collected about 150 samples from different parts of Michigan, and this is pretty much the similar research that I have started at UTSA right now. So at UTSA, University of Texas San Antonio, so we initiated this research and collecting honey samples from different regions of Texas, so we can find the bioactivity potential of Texan honey. And then after collecting these samples, we look for the components of the honey. So like the color analysis, both physical and chemical, antioxidant, and antimicrobial properties of honey. So we analyze them. So I'll go into details about them a little bit, and I'll share the results with you. First of all, we went through the physical analysis. So we will look for the moisture content of the honey, and it's pretty important because the moisture content of the honey can affect the the fermentation of the honey. And color analysis, and remember we said we have varying colors of honey, and according to the Honey Connoisseur Color Guide, thanks to Marissa, they have made this color guide for us. So the color of the honey can go all the way from water white to dark amber. And then these can be measured by the P-Font analysis or ABS 450. So depending on so we cannot directly tell by eye, but we can put them onto the microplate reader, and we can find out what is the exact color of the honey. So again, and there is a correlation between the darkness of the honey and bioactivity potential. There is a strong correlation between these, but it doesn't mean that there are some honeys which are white or extra white, but they still have high bioactivity potential. Again, this color guide is very helpful for us to have an initial idea about the bioactivity potential. And we also did the chemical analysis for the pH, for the acidity. And remember, pH of the honey is very important for prevent the growth of the bacteria. And also we look for the hydroxymethyl furfuryl amount, which is HMF, for if the honey has been heated or heat processed. And then the proline is important because it tells us that it is a honey. Sometimes, honey is one of the most adulterated food product in the world. So that's why proline is something that most of the time it shows us that it is less adulterated or not adulterated at all. And also we look for the sugar contents like glucose, fructose, and sucrose. Again, this is important for the adulteration of the honeybee. And then we look for the antioxidant activity, so which is the most crucial activity. First of all, let's talk about how does the antioxidant activity is helpful. So if you look about the formation of free radicals, so free radicals are the ones that are making us sick, and it is the major reason for the cancer as well. So this can happen because of an inflammation due to result of metabolisms, smoking, ionizing radiations, UV light, air pollution. All these components, they create free radicals, and these free radicals will cause DNA damage. And this DNA damage can result in either apoptosis, like death of the cell, or it may end up with cancer. So because the DNA damage, if it is not fixed properly, it can cause overproliferation and can end up with cancer. So how does this work? Normally the free radicals that has been produced by those agents, they will try to steal an electron from the healthy cell. So they would like to get those electrons. So what the antioxidants do is they have additional electrons that they can easily share with these free radicals. So they will scavenge the free radical, or they will just help the free radical not to go over and then, you know, attack the healthy cell. So that's why a diet rich in antioxidants is very helpful for our cells to live longer and then to avoid cancer. So what kind of foods they have antioxidants? I mean, most of the dark color foods, we would say, like the purple grape, the acai berry, the pomegranates, blueberry, kiwis, cranberries, they all have different amount of antioxidants. But I mean, for several years, we keep modifying these products. Unfortunately, they have lost some of their antioxidant values, or they lowered their antioxidant values. So again, by consuming these food, I mean, mostly the fruits, so we can have our antioxidants on our daily diet. But most of the time, we need additional antioxidants to fight with these free radicals. So in order, I mean, total phenolics are very critical to measure the amount of these antioxidants, or how we can find out the amount of the antioxidant potential of the honey. And I mean, this is a supplement that can be purchased like from the stores or from grocery stores. So we can use phenolics, I mean, to come up or to overcome with the with the free radicals. So, but normally we can easily get from the fruits or like natural products, and especially the honey. So for this one, what we did was we used the spectrophotometric Folin calculator method, and we found the results in gallic acid equivalents per honey. And then we also look for the total flavonoids. So this is, again, it's an important factor of the antioxidant activity of the honey. And we will look for different colorimetric assays for this. And then the last one is the radical scavenging activity. So we both use DPPH and FREP assays. So these are two assays that help us how those free radicals are scavenged by the antioxidants. And this is a very critical, very critical indicator of antioxidant activity. So that's why we measure the FREP and DPPH. And in this next part, we look for the antimicrobial activity of the honey. Again, in order to decide which honey to use for bioactivity potential, we really need to identify antioxidant and antimicrobial activity. And again, as we covered in the morning, there are so many different antimicrobial properties of honey that can prevent the reproduction of the bacteria. So, such as they can prevent dilute the membrane, and then or they can attack to the DNA's activities. So they can, the antimicrobial properties can be seen in different ways. So, and then in our studies, we study two different bacterial types. One of them is Staph aureus, and then the Pseudomonas aeruginosa. So the Staph aureus is the bacteria that causes disease in wounds, bone, and pneumonia. And then Pseudomonas aeruginosa is the one that, it's an opportunistic infection. It is mostly in the hospitals and immune suppressed patients. So we really would like to see how these honey samples that we had, how do they affect the growth of the Staph aureus and Pseudomonas. So in order for this one, we used the disc assay. So we put the honey into the center. We made a hole in the center of the Petri dish, in the agar plate. And in the agar plate, the hole is filled with honey, and then we grow the bacteria around it. And we measured the zone of inhibition. So how does the honey can inhibit the growth? And as you can see, different Petri dishes, they have different zone of inhibition. And we also upgraded to this a microplate reader. Instead of just doing on the Petri dish, we analyzed them on a microplate to measure all 150 samples in a shorter amount of time. Otherwise, this will take, very, very long to do all of them on Petri dish. So we improved our assay for this. Okay. And out of all these activities, out of all these antimicrobial antioxidant activities, we come up with a new level of termination, a term, so which is called bioactivity level, or in short, it's called BAL. So this BAL, bioactivity level is the formulation of antioxidant activity, antimicrobial activity, and physical properties of honey. So we came up with a formula to be used, for each honey sample, that the honey sample will have its own BAL or bioactivity level. And before we go for bioactivity, I mean, there are two important key terms for this. So bioavailability, I mean, normally when we consume something, some of the products, some of the things that we eat, like plastic, for example, our body cannot digest it, and it goes directly to from the bowels that goes to the toilet. Or or the cellulose, like for example, when we eat the plants, the cellulosic parts will just go through the bowels without any digestion. So bioavailability is the one. It is for nutritional efficiency. So we get the food in our body, and then this food has to be digested. So there are two terms for bioaccessibility and bioactivity. So bioactivity is the one that, like, when these molecules are interacting with each other, with the body cells, and it is important for the metabolism of these components, and then they can be used for energy, and also our body has a physiological response to it. And bioaccessibility is the one that once this food product is digested in the stomach and in the intestines, they need to be absorbed or assimilated through the bowels, through the epithelial tissue within the intestines, so they can be used. Again, for example, dry pollen, or some, like, for example, if you directly eat propolis or some other products, so their bioaccessibility is much lower when compared to honey or some other food products. So out of these, what we did was, I mean, by using these physical properties, antimicrobial and antioxidants, we gave them the BAL range, so bioactivity level. And we also color coded them. These are not the colors of the honeys. These are color codes of the BAL range. And then we divided all these 150 samples into 20% of increments. And then we named them as very low, low, moderate, high, and very high. So we has as high as 600 BAL, BAL value, and we have as low as 63 BAL value among the samples that we have analyzed, those 150 samples. Okay, so what about the results? I mean, out of all these 150 samples that we have collected in the state of Michigan in 2018, actually, this is a study from there. So we have analyzed these samples according to the International Honey Commission's standards, or IHC. So IHC is the standardization method for analyzing the honey, not for adulteration, but mostly for bioactivity potential. So actually, how should I say it? No, it's also both adulteration and bioactivity potential. So there are some standard methods, and there are also some methods which has been developed out of these IHC standards as well, so which can be applied for bulk analysis of the honey samples. So for the physical analysis, again, as we mentioned, I mean, honey has different colors from water white to dark amber. And then for this one, we did the honey color analysis from P-Fund range. We have as high as 143, which is above the dark amber among our samples. And then we have all 0 as well, I mean, in the P-Fund analysis, so which some of the samples were water white, like just, it's honey, but just like water. And then moisture, it was interesting that we used the Brix method for the moisture. So the moisture was from 13.5 all the way to 21%. So some of the honey samples were highly moisted, especially this one was not from Michigan, but somebody donated the honey from Hawaii. So this sample from Hawaii was pretty high. And then we have the pH all the way to 2.8 to 507. Okay, yeah, this is the Brix method that we have used. And again, I already mentioned like 21% from Hawaii and then 13% from Germany honey. Actually, we had also German honey. And in terms of the pH, I mean, again, different foods or different products have different pH values. So most of the honeys that we have, so they are between 3, 4, and 5. So which is the similar pH values like the soda or energy drinks or popcorn or all the way to coffee. So, and honey is mostly has acidic pH. And we have as low as 2.8 and we have as high as 5 pH within our samples. And then in terms of antioxidant properties, so remember we measured the total phenol contents with the GAE, gallic acid equivalent. So we have as low as 5, but as high as 800 GAE. So this is kind of above so many other phenol contents when compared to the other samples. And we also used FRAP, and it was from 156 to 1977. Why these are important? Because I mean, when we see, so when we look our samples, all those 150 samples, we have like phenolic contents all the way to almost 800, 793, and sorry, 806, and then we have all the way down to like 5.29. So these honey samples are being either monofloral or multifloral, so their phenolic contents change throughout the state. I mean, from different regions of the state. So we had all different ranges of total phenolic contents. And this is, again, another important indicator that not every honey is equal in terms of the phenolic contents or other components. And again, in the FRAP, so ferric reducing agency, it is this one is pretty much correlating with our phenol content results. And again, we have some samples, like varying amount of samples, like varying amount of FRAP values among the 150 samples. And in terms of antimicrobial activity, there are some surprising results in here. Because we could not go all 150 samples because we need to do triplicates, and then 150 samples was too much to finish. So we just like with the high TPCs, like high total phenol contents, we just continued with them. And we applied these honey samples to Staph aureus and then Pseudomonas aeruginosa. And then we put them into 96 well plate. So these are the bacteria, the dull yellow color, and the bright colors are the ones that are either control samples or just when the bacteria could not grow on those samples. So when we applied the honey, some of the bacteria, I mean, died within 24 hours, and they could not grow within the presence of that honey sample. So what we did was, this is very interesting in terms of Staph aureus. So we have 91% of inhibition, so which is pretty high. I mean, these are the ones that had inhibited the growth of the bacteria, like H7. This is honey sample 76, and we have 117 and 130. So these are the highest one. But in addition, there are some samples who promoted the growth of these bacteria. So it is very interesting for us to see that some bacteria promoted the growth of the honey. Some honey has promoted the growth of the Staph aureus. And this one is more surprising for us because Pseudomonas aeruginosa is an opportunistic bacteria. So they will use whatever they have. And again, this is also clearly shows that not all honeys have antibacterial activity. In some samples, for example, we have like up to 26% of inhibition, like H7 and H30, H6. So, but on the other hand, we have some honeys that has like 40% growth of these bacteria. So some honeys has promoted the growth of these bacteria. On the other hand, some honeys inhibited the growth of this bacteria. And again, this is a sample study, and this study has been done by my students who joined the summer class. Okay. And out of all these, we had the bioactivity levels. I mean, the BAL levels we came up with by using the color, pH, moisture, total phenolics, FRAP, and antimicrobial. Because this BAL level or the BAL value will give us the idea which honey can be used, which honey has the highest bioactivity potential. So if we can find this, I mean, if we can identify those honey samples, and then we can use them for animal studies, for clinical trials, or even at the beginning, we can do it for cell cultures. So in order to recap what are the biological activity potential of honey, again, the high sugar concentration, the acidity, and organic antibacterial compounds. So this is the key for us to identify which honey can be used, and also hydrogen peroxide. In our current study that we will do in Texas, so we are also looking into the hydrogen peroxide activity, which is a very critical indicator for antimicrobial activity of the honey. So, by using these values, the antioxidant, I mean, total phenolics, and as well as the FRAP activities, all these activities, when they are combined, when we came up with the formula of the BAL, so we found out, again, there is a very wide distribution of the BAL values of the Michigan honeys, or 150 samples. So the highest amount of was 673.18. This is from the buckwheat honey, actually from Green Toe Gardens. So we found out buckwheat honey has the highest amount of bioactivity level. And then we have another one, which is 63, one of the lowest bioactivity levels. But again, this doesn't mean that low bioactivity level does not necessarily mean that that honey is not useful. It is still useful. It is still can be used for daily production, daily consumption. It still can be used for minor cuts, but not for big wounds, or not for, after a C-section. You should not be using these honeys, but you should use the honeys with the high bioactivity level. So again, this will change from, so this is a kind of a guidance for us, which honey to use. And again, we gave the values, like about 20% of them, the highest was 164, about other 20%, 135. So this is a very short range, actually, like only 30 points. And then here, another 25 points we have, and then we have another 40 points. So again, the bound range can change. But among our high bioactivity level, which is the top 20% we arranged, so it's a big gap. Not big, but a big opening, like 204 to 673. So which are the best ones? Among the high bioactivity levels, we can see the Manuka pill. So this is like, again, these we have high and very high. So the Manuka honey that we got from Manuka Med, I got it from one of the conferences that I joined for the wound healing, and Mega Honey from Dermasciences. This is the most common Manuka honey that is being used in the clinics. So, and this is FDA approved in Canada, not in the United States, but Medi honey has been used, in the clinic the most. And when we give our BAL values, as you can see, it is about 166. And then the Manuka pill, the other Manuka honey, which is again, this has been used for clinical trials, not trials, but actual clinics as well, it is 182. But if you look at other honeys that we have in our studies, which are very high, so we have this buckwheat honey, and again, this is another buckwheat honey. And I think the top 3, or out of top 10, I think 5 or 6 of them are buckwheat honey. I'm sorry, I didn't write their sources. But we also have forest honey from Germany that we used as a control. And this is the honey from Turkey. This is chestnut honey that has been used. And again, we have different honeys from different donors that they gave us for the analysis. But again, among these top 10, we have 5 or 6 of them were buckwheat honey. So which shows that, buckwheat honey has a much potential in terms of bioactivity level than the Manuka honeys. Okay, and in conclusion, again, this is for Michigan honey, but we can easily say a very similar thing for Texan honey, because honey is out there for thousands of years. So, and honey has been used like for medical purposes or for wound healing, for different, treatments of the diseases for so many civilizations. So for this reason, each honey should have its own property. So, and the objective of this research is that to find out which honey has a higher potential, bioactivity potential for some of the major diseases that is hard to treat. So, as a result of this study, we can say that some of the honeys with the high BAL values or bioactivity potential, they can be used as a complementary in medicinal and veterinary treatment. And this shows that it's a reliable method to identify or to classify the honey samples. And then, however, in order to use this one in the clinics, we need to do more evidence-based future studies, like in the cell cultures, and we need to study some other bacterial samples. So it's a long-term study, it's a long-term research, but this is, for us, this is a very good starting point to find out which honey we will use in our further studies. And what we did was, as a result of this study, so we found all honey samples, they have different levels of bioactivity potential. And then we can give official certification from the work. And this is the certification that we provided for the beekeepers who donated their honey samples. And this certification, can be used to promote their honeys, when they sell it. Because if you can tell them, and also there's a explanation here, among how many samples this has been done, and then how they've been analyzed. And these results of analysis are valid only for the sample product by the donor and do not include any other products. But at the end, if you try to sell your product, you have a very high value of bioactivity potential, and it is extra white, as I mentioned earlier. So this is an extra white, but very high potential. So, I mean, you can help to analyze, I mean, to arrange the selling price of your honey based on this certificate. And again, this is from Alma College in Michigan, but right now I'm working with UTSA, and we haven't finalized with the certification process yet. But once it is, approved by university, everything runs well, so we can certify the honeys of the producers, the beekeepers, to find real Texas honey with high bioactivity potential. So I think this will be a great opportunity for marketing of your honey to be sold, I mean, for varying levels of prices. And again, this gives us the medicinal potential of honey. I already covered them in the morning. I will not go into details, but I mean, if you go to the Amazon, or if you go to the other websites, that when you look for medical honey, there are a lot of them already on sale. And I mean, if you can see, this is the Manuka honey is $120 per pound. So once the beekeepers just sell their honeys for $4 or $5 per pound, or I don't know the exact prices of them, but on the other hand, when it becomes medical honey, the price jumps all the way to 120. So it's like at least 6 to 8 times more. The price can jump that much. So when it has been identified as with his medical potential. So, and there are different products of medical honey, like the gel or the Band-Aid. So you can put the honey embed the honey into the Band-Aid, and it's just a couple of less than a gram or 1 gram. And then this will be an antibiotic Band-Aid. And, or you can do big gauze pads, and they can be used in the surgical procedures, or even after C-section. I mean, the honey can be applied into the C-section area, and then it will improve, or it will enhance the, enhance the healing of the C-section much faster without an infection and without a scar. So again, there are a lot of values of honey to be used in the medical and veterinary use. So, and there is a big market for this as well. So again, we need to do evidence-based studies for cell culture, animal studies, and clinical trials. And these are our upcoming studies at UTSA. And hopefully we're going to work with USDA as well. So I'd like to thank you all for your time. I mean, these are my student groups. Sorry. These are my students that we did the study together. And this is the class that I taught in Alma College in Michigan. These are medicinal honey. And these are all my students that we worked together for the summer to finish this analysis of bioactivity potential of the Michigan honey. And I'd like to thank for the UTSA and also Michigan Beakers Association. And I can have questions.
Sweet. Thank you so much, Dr. Ozturk. I greatly appreciate it. And I also appreciate that you skipped quickly past the images that you showed this morning. Those were some pretty gnarly wounds indeed. Real quick, before we get into the questions, Sharon, I do think I saw your hand raised, and I went to ask you what you needed and I accidentally removed it. So if you did have a question, make sure to go to the bottom of your screen, put it in the Q&A box, and that will pull it up here so that we can go through and answer those. We do have some questions out there. I have some questions for you too. Sure. So we can kind of go back and forth, and we have, unlike our other presentations, we finally caught up. So we have some time. We can dig a little bit into depth on this.
I really want to cut it short so that we can have, I know the more questions will come. And again, sorry for skipping from one presentation to another. That's kind of made the things a little bit tricky.
Hey, you did great. There was no issue with switching between it. I have to switch between 3 different monitors, so you did amazing. So our first question is going to come from Anissa, and they would like to know, does honey help with allergies? So this could be a controversial question and answer, but she says, people, including medical professionals, claim that it does, but I've yet to find any actual studies stating that it really does. So how do you feel about that?
I mean, before I discuss with you, I had a strong belief that honey helped for the allergies. But remember in the hive drive that we had, because not every pollen, not every tree has the pollen that honeybees are visiting. So the background of the honey helping the allergies, to help to elevate the allergies, is that because the honeybees, when they visit the trees or the flowers to collect the nectar, they also collecting small amounts, minuscule amounts of pollens, and they put these pollens into the honey. And once you consume the local honey, you are also consuming some local pollens into your body. And your immune system is recognizing these pollens, dangerous, but not too bad. I mean, they just recognize them. This is something coming from here. And once you got the allergy, I mean, once you get those pollens coming to your nose and then making you like feel uncomfortable, no, your immune system will tell, no, this pollen, I know him or her, whatever. So I know it. So there's no need to rash. There's no need to release the histamines. And, I mean, there's no need to panic. So that's how our immune system is learning about this. But in order for this theory, I mean, for this thing to work, the honeybee has to visit the pollen, or visit that tree or a flower that has the pollen in it. And in Texas, I think we have the cedar allergies, right? Most of those, and then cedar doesn't have pollen, or it has the pollen, but the honeybee doesn't visit.
It does have pollen, but it releases its pollen during the coldest time of the year when the honeybees are not actively foraging and there is no nectar for them to bring in and make honey. Therefore, it usually does not get mixed into anything if they do go and get it to begin with. And that's a challenge with a lot of things. So, if you looked at it from that standpoint, ragweed potentially bees could visit the ragweed flowers, bring the pollen back. That could actually be mixed in there because that would be at the tail end of the nectar flow. But things that the most people complain about, like you said, cedar fever is a big one, and that probably is not going to be helped with honey.
Yeah, but on the other hand, honey help it's an immunomodulatory product. I mean, it has immunoboosting effect. So which means that it helps our immune system to be ready for these kind of rashes or attacks or like allergies. So consuming honey regularly may help alleviate the severity of the allergies. Again, I cannot say it prevents the allergies, but at least it can help your body to fight with it in a much milder way. But I don't have any studies in hand that shows it. So just theoretically.
Take it with a grain of salt or a teaspoon of honey. So our next question is from Wendy. And Wendy was stating that during your presentation, you were talking about honey promoting bacterial growth. And she was curious if that specific honey had instances of higher moisture contents or not.
Actually, I have not analyzed from that perspective, because what we did was we were adding 10% of the honey into the bacterial growth medium. So we added like 10 grams for 100 ml of the medium, and then we just diluted medium into the bacteria. So if we come out like the moisture of the honey, I don't think it will be that much of effect, because if you get 10%, so it will be a very minuscule change in terms of the moisture, but it is worth to see it. I mean, I can go back and analyze my data to see if the high moisture content has caused the high bacterial growth. I mean, that's a great question, and it's really helpful. I mean, it's worth to have a look at it, and I'm taking note of it.
And you're making notes. Well, while you're doing that, we still have some other questions over here. And again, I still have some of my own that I kind of want to throw curveballs at you just because I can. So Kathy would like to know that she's read about a lot of people selling adulterated or diluted Manuka honey. And as you mentioned in your first presentation, honey is like one of, if not the largest adulterated food products, next to like olive oil, I think is number 2, something like that.
Yeah, they changed.
Yeah, they're kind of neck and neck. So she wants to know, how do you actually know if you're buying medicinal honey, if it's actually really what it says it is, if it's pure or not?
I mean, Manuka is, again, the most adulterated honey in terms of honey, because I thought it was a joke, but I heard it from several different locations. So Manuka honey has been produced 10,000 tons, and it has been sold 100,000 tons. So I mean, something 10,000 with 100,000. It has been diluted about 10 times. So, I mean, there are so many fake Manuka honeys that is, on the product scent. But on the other hand, I mean, the New Zealand government and also Australian governments, they have put a lot of like different ways of finding out, like separating the genuine Manuka honey from the adulterated ones. So they have 5 levels of security to find out if your Manuka honey is actual Manuka honey. So they have batch numbers. I think there is a QR code. There's the hologram on it, and there's the producer number, something like that. So by going to the in the Manuka honeys, if it is genuine Manuka honey, it will have all these security things, and you can go to, I think in the forgot the website, but I can find, like, you can maybe Google like genuine Manuka honey in New Zealand, like identification, something like that. So it will bring you there, and then it will just like, you enter those numbers and it will tell you who is the producer, when it was produced, and then how it was processed and where it is sold, kind of. It has all the trace. So that's why it's expensive. I mean, because
Right.
when you have something very good, then you will have adulteration. I mean, you will have people who will just, copy it or just make the fake ones.
Yes, that's very true. And it's unfortunate. It's one of the biggest reasons, even outside of the medicinal aspect of it, that beekeepers have a hard time competing with the amounts that they find or the value of the honey that they find in the store, because it is being brought in from other places. They're selling it for pennies on the dollar. And, we try to basically just educate, and, the word of mouth and the education on what real honey is and why you should get it from a local beekeeper is really our only kind of advocate that we can use to counter that, because it is really hard. We want to sell our honey for a minimum of $10 a pound. I know you mentioned earlier you weren't sure, but
I know the prices.
Yeah, here in our area, we recommend usually about $10 a pound at the minimum, and then up from there based on the type of container, volume, things like that. So it can definitely be challenging. We have a couple of other questions. I'm going to slip one of mine in here just to kind of throw a little curveball, because I'm kind of curious. So most of the time when you go through and you see medicinal honey and you pick it up and you read it, it states that it has been sterilized. And I know that, in past talks with you and I, that if you heat the honey, you're invalidating all of those bioactivity levels and everything else. You're turning it into basically just a sugar substitute. So how are they sterilizing it? And is that actually compromising the medicinal aspects of it?
I mean, majority of these sterilization studies have been done by Australian and New Zealander like researchers or UK researchers. There are not so much honey studies in the United States, unfortunately. So, but when they did, okay, the honey that's being used for medical purposes. So they are being sterilized by gamma irradiation. So you can sterilize the food products or other things by heat, by gas, or by water pressure, all those things, but none of them will help for honey. So for honey, the only way is gamma sterilization. And then they found out, I mean, a group from Australia, I think University of Sydney, I believe. So they found out when you increase the amount of gamma sterilization or the time, it doesn't affect the antimicrobial activity of honey. So it doesn't affect that much. But again, I mentioned in the morning, but gamma sterilization or sterilization of honey for medical purpose is only to get rid of those spores, which may grow on the top when it is applied topically, which may grow on the skin. So these spores need to be neutralized by gamma irradiation. But and these spores are mostly coming from unhygienic honey harvest. So for example, if you have an open area and then if you harvest your honey in an open area or like airflow, those spores are in the air and they can just land into your honey. But if you are very careful, if you follow all the hygienic guidelines to prevent the spores, like in a clean area, well-ventilated area, I believe you will decrease the chances of the spores ending up in honey. And unsterilized honey still can be used, not in the medical, but for personal use or for home use.
Very good. You mentioned towards the end of your presentation, real Texas honey, and you did quotes, you can tell if it's real Texas honey or not. And Harrison Rogers is on the board for the Real Texas Honey program. So for those of you who don't actually know, we really do have a Real Texas Honey program, and you can go to Real Texas Honey. I think it's .com, but it may be .org. But if you Google Real Texas Honey, it'll come up. You can find, there's a honey locator on there where you can actually go through and find individuals in the state of Texas that are selling honey that have actually been vetted, and we know that it is legitimate Texas honey. It's not being imported from other places. And that way you can actually find a beekeeper near you. So if you're looking for honey, go check it out. If you are a beekeeper and you have excess honey to sell, or you want people to be able to find you and know that you do provide real Texas honey, you can actually apply to be part of the Real Texas Honey program. So definitely go check that out. Harrison, just wanted to say kudos in regards to that and put a little plug in there because it was a perfect segue. So let's see here. Kathy was going to go back real quick and touch on buckwheat honey. And before I ask that question, I'm going to put a little thing out there just to irritate people. But Manuka honey does not taste good. Manuka honey is kind of gross. And buckwheat honey is just absolutely vile. So in my opinion, the worse the honey tastes, the better it must be for you. That has to be the logic. But so Kathy would like to know, are any specific types of buckwheat honey different from the others, or does buckwheat in general have the same values and properties?
I mean, again, I go back to the same point, but not every honey is created equal. So the buckwheat honey that you get this year from this location is not the same buckwheat honey that you will get next year from the same location. So again, the amount of nectar flow may change depending on the rain or depending on the sunny days. So these kind of things affect the amount of buckwheat inside, the pollens of the buckwheat in the honey. So the concentration of buckwheat, I would say, it may change from year to year, from location to location, from source to source. That's why we need to do BAL analysis. So that's why we need the laboratories to say that this honey from this location on this year or this season, it has high bioactivity level. But overall, what I personally do is, I trust buckwheat honey the most, among the bioactivity levels. And because I haven't analyzed Texas honey yet, so among my analysis. So that's why I just buy buckwheat honey from North, and then I just use it for my, when I have a scratch on my hand or when I have some infection, or even this morning, I didn't have the photo, but I can show it to you. So I apply, on my face, the,
like a facial treatment or a facial scrub. You put the honey on, and
yeah,
I think the screen is switching it up, but
yeah. But anyway, so I apply honey to my face as a mask after shave. So,
hey, there you go.
And it prevents all these bumps and all these. It prevents the infection as well. No redness. So it's very helpful, and people can use it. Okay. Yeah.
Okay. So our last question over here in the Q&A section is. And I'm going to bet that I know the answer to this just out of, because again, like you said, you're just starting to test the Texas honey. So
please send the samples.
Yeah, send the samples. And so Rogers Apiary would like to know, has hot honey, quote unquote, and hot honey is actually honey that we get from snow on the mountain or snow on the prairie. And it is, it definitely, it almost has like a capsaicin kind of like heat to it. And so he's curious if that has ever had the ball test as of yet.
I'd love to test it again. This is the problem is it's not very easy to find monofloral honey when we do the analysis. So if you have hot honey or snow on the mountain honey or any other monofloral honeys, please send it to our program. Send our lab, and we'll be happy to analyze them once we start doing them. And most probably we will be doing them in spring, and it will be ready by summer. Our analysis we can get, ready to be, shared.
Yeah. And so there was another thing that had come up in the chat section, kind of on the private side of the chat. And I wanted to go through and address it. So as everybody watching today knows, we did the honey show just a couple of weeks ago, and we did ask all the participants for the honey show if they would be willing to submit in a sample of honey that we could then send to you so that you could start doing this research on it. And when you and I had originally talked, and if this has changed, this is your moment to feel free to correct me. But when we had originally talked, anybody that did send in that sample, as you guys went through and you started doing the research on it, you were going to provide them with a pollen analysis of what pollens were in that honey sample. And that is a thank you for them basically submitting it in. If anybody was willing to also do a monetary donation towards your research, then you would go back and provide that certification of the actual bioactivity level with the college certification letter with that. Is that correct?
Yes, but again, we have not still finalized our agreement with the UTSA, because it will be the university's logo and all those things on it. So we have not finalized with my PI yet. So, but definitely, we'll be happy to provide, if even it's on the certificate, I'll be happy to share them as an Excel file or so that can be used. And again, we'll be so happy to, because eventually once these things are established, the certification will cost a little bit more than this. So just like first come, first serve.
That's true. And as you get more and more samples in, you'll start actually having a kind of a backlog that'll start up. I know that I have a box of at least 30 to 40 containers sitting over here that will be going to you next week. So
That's And I mean, for the honey adulteration, I forgot to say, yeah, I don't know if you have watched the Food Wars about honey, and that one is it's on Netflix. And if anybody's interested in honey adulteration in the world, and especially how it has been like fought in the United States, I would really recommend to watch that one, the Food Wars about honey. So it is, I mean, I really with the numbers, I mean, the amount of honey that has been poured in the United States and lower the prices of the honey so badly.
That is insane. Well, I appreciate the recommendation there. I've seen the I think the documentary Rotten that has like the different series. I've seen their segment on honey, but I have not seen the Food Wars one, so I will check that out.
Sure.
So any other last minute questions? I don't know that we took care of everything that was in the Q&A thing. I don't see any pending ones in the chat. So if no one else has any questions, then Dr. Ozturk will go ahead and let you go. Thank you so much for joining us today. I greatly appreciate it. I look forward to actually seeing you here in just a few days, actually, when we do the exchange for the honey. So, but again, thank you so much for your knowledge and expertise.
Thank you so much.
It was absolutely fascinating. So we really appreciate it.